Hello and welcome you all to this section 4 lecture 2. This is continuation of subnetting class C, but this time we are going to do some practice questions which are scenario based. Class C table modified for our need of subnetting. So this was the table that we have already seen earlier. Now I have just done some little bit of modification so that we can use this table for the purpose of planning our network based on the given scenario. So subnet mask, prefix length, number of networks, number of hosts per subnet. Okay, now this is the host condition. How many hosts per subnet? So in this case, let me start with the bottom when it comes to the host, because bottom is the lower number. When it comes to network, let me start from top to bottom because this is the lower number. So let me go to the next slide where I have done this. Okay, so whenever you want to do your calculations based on host conditions, so we look at these numbers. Okay, how many hosts are there? 2. If only 2 hosts are required in the given subnet, then we use /30 prefix length or 255.255.255.252 as the subnet mask. In that case, we will have 64 different subnets and we can have only 2 hosts per subnet. If it is more than 2 hosts but it is up to 6, so 3 to 6 we use /29, or this is the corresponding subnet mask. If you have more than 6 hosts, so 7 through 14, so up to 14 we use /28 as the subnet mask, prefix length, and this is the corresponding subnet mask. So this is the range. If we have hosts within this range, then we use the corresponding prefix length or the corresponding subnet mask, and they will give us this many networks for that particular value. According to the network, if you need only one network, then we use /24, which is the default. If you want to have 2 networks, then we use this corresponding value /25, or this is the corresponding subnet mask. If you have more than 2 networks, 3 or 4, then we use this one. If you have more than 4 networks but maximum of 8, then we use this one /28. So these are the values based on number of networks, and these are the values based on the number of hosts. So we are going to extensively use this particular table to answer our scenario based questions. Question 1. Your boss wants to design one network with 50 hosts in it. He wants to use class C private range 192.168.12.0. Now here the network has been mentioned and there are 50 hosts. So what would be your design as per this need? Now some explanation is given over here. Please go through that. I will just look at this 50 hosts. So where does this 50 lie? So 50 is more than 31 and it is less than 32. So if I use this, I can have a maximum of 30 hosts. So all these are not my requirement based on the number of hosts. I can use this, but there are many. I have got 50 hosts, so I will use this one, although there is a space of 12 extra hosts. So we will use this particular subnet mask or this particular prefix length, and after using this I can have 4 different subnets in that particular case. So as per the question, 12.0. So my new subnet mask also I need to write because it is this one. So new subnet mask would be 255.255.255.192 or /26. So just make use of this table and decide what should be your structure, what should be your plan. So it could be based on the number of hosts, or it could be based on number of networks. Let us see next question. No next question. Okay, so the answer for the previous question. So because the subnet mask, what is the subnet mask? 192. So 192 has a block size of 256 minus 192 is 64. So my first network would be 12.0, next would be 12.64, 12.128, 12.192. So these are the four subnets. Let us verify. Between 30 50 lies over here, so there would be 4 subnets and the block size would be 64. Sometimes what happens, the question will ask you, I need to use 192.168.12.0, but I need to use the third subnet. So if they say third subnet, this is the first, this is the second, this is the third. If the question says in this use the second subnet, then your subnet would be 12.64. So we have to be extra cautious, although it is 12.0, because it has not mentioned exactly what particular subnet, so we stick with the first subnet. Sometimes it will say it is 12.0, but in this it is the fourth subnet, so it would be this one. So in that case your subnet would be 192.168.12.192 and the broadcast would be this. Question 2. Your boss wants to design one network with 100 hosts in it, and you need to use 100.0 as the class C IPv4 network. So where is 100 hosts? Just go into the table. So 100 lies between this 63 and 126. So I will use this particular subnet mask or this particular prefix length. Remember, the interesting octet is value is 128. So the block size would be 256 minus 128, which is 128. So my first network would be .0, second network would be .128. So in this case it is 100. So first network would be 192.168.100.0 and the second network would be 192.168.100.128. Easy to understand with the help of this table. Keep this table ready. This is for class C. Your boss wants to design a network with 150 hosts in it, and this should be the network. So what should be your design? So 150 is in which part of this table? 150 is in this part, so we will have only one single subnet. So this is the default one. Where is it? 126 hosts less than the requirement. How many hosts are there? 150. Okay, so 150 lies over here, so we use the default one. So in default there will be only one network, so .255 would be the broadcast address. The subnet mask would be 255.255.255.0. This is the first valid host, second valid host, all the way to the last valid host. Your boss has asked you to design a subnet which uses the fourth subnet. Now this is the specific subnet of 192.168.50.0 network and has at least 10 different subnets. Now this is based on number of networks. 10 subnets means 10 networks. So let us go back to our table. So I need to have a minimum of 10 networks. So this is my table. Now I look at this one. One network, 2, so 10 lies between 9 and 16. So based on that question, I will use this subnet mask. But remember, this question is asking the fourth network. So this is 240. 240 means block size of 16, and there would be altogether 16 networks. So remember, block size of 16. This is the fourth network. So 50.0, 50.16, because block size is 16. You remember 255.255.255.240. So 256 minus 240 is 16. So 16 is the block size. So this would be incrementing with multiples of 16. First being 50.0, then 50.16, 50.32, 50.48, all the way to this. But we don't need to calculate, just calculate up to the fourth one, or keep this whole table handy. So this is my required subnet, and this will have a subnet mask of 255.255.255.240. Now summary of section 4. Section 4 was subnetting class C. So this is the third video on that. First video we borrowed first 4 bits. In the second video, bit number 5 and 6, and we saw the special cases. Why can't we have /31, and how do we use /32? I gave the examples of routers. Then we saw the third video, in which we saw few scenario based questions. So in the exam they could ask you question to plan or design a network based on number of hosts, or they could ask you questions based on number of networks. Okay, summary of section 4. Class C, 192.168.0.0/24 through 192.168.255.0/24. These are the private IPv4 class C free addresses. So if you summarize them, this becomes 192.168.x.0/16. Summarizing is very important when we work in large enterprises. So whenever we have multiple contiguous networks, instead of writing them separately, we write them at once. We do define them, but when we send the summary from one router to another router, we summarize and send so that it goes in one line, and that saves the space of the memory. Total number of free private subnets is 256. Class C public IPv4 address we have already seen. Why did I write it again? Sorry, this is public. So 192.0.0.0/24 through up to 167, because 168 series is private. So again we start with 169 all the way to 223. Borrowing bits from the hosts to increase the number of networks consequently reduces the number of hosts per subnet. We have seen this, correct? So with /30 we have only 2 hosts. /29 we have 6 hosts. Go through that table. So 256 minus 2 is 254. Always we have to subtract 2. How I remember is 256, 128, 64, 32, 16, 8, 4. So 256 minus 2, 254, and then 128 minus 2, 126, then 62, then 30, then 14, then 6, then 2. Interesting octet's decimal value gives magic number. Block size is equal to 256 minus magic number. The new subnet mask formed after subnetting. So from this value we get the new subnet mask. How many bits have been borrowed? So based on number of bits borrowed, we get the binary of that particular interesting octet, and from that binary we find the magic number, and then we find the new subnet mask for the new subnets. All the subnets will have the same new subnet mask. New number of hosts formed after subnetting. So when we do subnetting, we borrow bits from the host. So network bits increases, host bits decreases. So as the host bits decreases, number of hosts also decreases. Subnet mask or prefix length required when connecting two routers for WAN connection is /30 or 255.255.252, giving two valid hosts, one for the interface of the first router, another for the interface of the second router connecting those two routers. Subnet mask for a single host is 255.255.255.255 or /32. /31 is not allowed for us to use because there are zero number of hosts in that. We have seen class C modified table according to our need. So this is based on number of hosts we require in the network, and this is based on number of networks we require for our organization. Please go through these three videos thoroughly and make sure that you write these things. That should be all in this particular video, and that should be the end of class C subnetting videos. Thank you very much for watching this video. See you in next video where we will start with class B subnetting with lots of examples. Thank you. Bye until then.